Writing out exactly what a coordinate map does is a little bit annoying just because there's so much to write down. But there's actually a little trick that we can do that makes it much easier to write down exactly what the coordinate map is doing. So suppose we have some subspace V and we have a basis for V, which is V1 through Vk, and say that C sub B is the coordinate map for this basis. So its domain is V, its range is Rk, and it takes any vector in V to the coordinates for V. Okay, fair enough, but how do you write down actually exactly what this map is doing? Well, V is since V1 through Vk are a basis for capital V, little v, we can write it as some linear combination of V1 through Vk. So it's possible to write V as this linear combination, and in fact, since V1 through Vk form a basis, the coefficients here are unique, right? There's no other way to choose A's so that this linear combination gives us little v. Okay, so what the coordinate map does is it sends this linear combination to the vector A1 through AK. Right? And then the inverse of the coordinate map, which goes from Rk to V, just takes the vector of these coefficients and gives you that linear combination. But there is an extremely nice way we can write down what this linear combination is. Right? Remember, a linear combination of vectors it's the same thing as if we had a matrix with the v's as columns and we multiplied it by the vector of a's. So it's the same thing as if we had this matrix whose columns are v1 through vk, and we multiplied it by this vector with the coefficients, right? So this way of writing it, what the coordinate map does is it takes this linear combination and just throws away this matrix of v's and just keeps the vector of coefficients. And then the inverse transform takes this coefficients and just multiplies it on the left by the matrix full of v's. So this makes it kind of clear that, since the v's are linearly independent, it makes it clear that this is an isomorphism, right? Because we aren't accidentally collapsing any vector down to 0 when we go this way from right to left, because collapsing a vector of coefficients down to 0 would amount to having a non-trivial linear dependence relationship among the v's, which we know we don't have because they form a basis, so they must be linearly independent. So this is a really nice way of writing what the coordinate transform is doing, right? The coordinates are just the vector of coefficients, and the vector that the coordinates came from are just those same coefficients, but multiplied by the matrix whose columns are all of the v's.